Good morning to all of you. Today, it's very privileged to be here, and thank you, Mitra, for providing this opportunity. What I'm going to do is to take just a couple of minutes, and 20 is the guidance I've been given, to talk about two things. One is the trends in the world that are happening, and second, the trends in the chemical industry. And it's very important before we start, taking a journey, and skill building is tough, right? It's taking you 4 years in engineering. If you pick up a course to become decently qualified in it, that's at least a year's journey, year and a half's journey. I think it's very important for each one of you to understand why you're undertaking that journey. What is it that's prompting? Otherwise you leave that journey midway, right? So when we talk about the trends of the world, there are three trends that I broadly see. So one is this hyper trend towards autonomous, right? So everything should work without a human. So today, it's not big companies, and it's not just NASA trying to do that. I have a small robot in my house which does the cleaning, the cleaning of the floor and mopping of the floor. So we always had vacuum cleaners and stuff like that, but someone needed to hold the vacuum cleaner and move it around. But this one, just creates a map of the whole floor layout, has simple collision detection technology, very simple, right? It sees an obstacle and stops there and moves around that part. And a simple vacuum cleaner, right? So to basically just pick up all mop and clean everything up. And if you think about it in the world, we made tremendous progress on autonomous cars. So just think about it. I don't know how many of you can drive at this moment, but starting to drive is one of the most harrowing experiences that one goes through. You think it's easy. You always sat on the next seat to the driver with your parents or friends or whatever. But just navigating that whole traffic, making sure you're pressing the clutch and the accelerator. But you know what? It's all getting automated. And Tesla's stock price is shooting up because it's at the point where it has developed a fully autonomous vehicle. So that's one big trend. And very interestingly, we'll come back to this later on and talk about why are people driving autonomous cars and not doing something big in the chemical industry, right? So why is this problem being attempted in the world and not the other one? The second part is platforms. So what's changing, and Uber is a good example. So if you think of Uber, you understand platforms. So, and you've heard this and read this a lot of times, but let it sink in for a minute. So Uber doesn't make a car. It doesn't make any parts. It doesn't own any transportation license to any country. And yet it transports more people across the globe than anybody else. And in a very short span of time, in about, I would say 5-6 years, it's achieved that milestone, and across countries, across not just one geography. And what it's done is basically it's created this platform where any car can be converted into an Uber car. And you don't need to bother whether it's a Ford car or Maruti car. It doesn't need to tie up with those car companies. You just put a phone there and suddenly it's an Uber car. And it's seamlessly linked to the mobile phones of all of us commuters around. It's linked to payment systems. It's linked to a great, driver accreditation system. We don't see that, but there's a system how to onboard drivers there. So that's another part, saying that companies are suddenly scaling 2x, 5x, 50x, 100x. Because they have a platform. Jio has a platform currently where it's moved from 0 to 400 million in a very quick space of time. Right? That's the second trend. So platformization, where you bring a lot of technologies together and then you create an ecosystem. So the ecosystem, generates value versus a car company generating value, or a banking company generating value, or a transportation company like Hertz generating value. The ecosystem is generating value. And there is no limit to that ecosystem, right? You can just go geographically anywhere. That's the second one. The third one is exponential thinking or exponential growth, right? So at this point of time, man has always been imagining a lot, right? They've been imagining, saying we can go to the moon, we can colonize Mars, but or that's more recent, I would say. But the thinking today of people is really exponential. It's not how can I cut 5% of cost, how can I cut 10% of cost. I mean, I was in the Silicon Valley, and we had a singular university. You must check them out and understand what exponential thinking is. The only two problems they're trying to solve there is how can man live beyond 150 years, and how can we colonize Mars. Everything else, someone is working upon it already. These are the two things where we need a lot of investment and thinking. And I'll give you an example, a real life example where people are doing exponential thinking. So, I mean, all of you have flown on an airplane, and every airplane has a turbine, right? The wind turbine, which is the engine which drives it. And it has a set of blades, right? And metals being metals, they'll corrode, their stresses and strains will impact them, and they lose their shape. And they need to be replaced every, I think, 18 months or 24 months. And given that it is, I mean, plane only has two engines and you're in the air, they are changed every 24 months and 18 months, right? So incremental thinking would have been, how do I extend it from 24 months to, maybe 26 months? How do I get a better coating on that? But just think of this, what GE has done there. What they've done is, in a certain, turbine blade, there's a set of blades, actually 36 blades in that set. So you don't need to change all 36. You only need to change the one that is getting damaged, or the one where the metal properties of strain and stress are changing. So it's 3D printed a ceramic gauge on the blades. So there's a blade and there's a ceramic gauge over there. And every time, the plane comes in for inspection to the airport, the machine runs, and there's an infrared which checks whether that gauge has changed. So has stresses and strains impacted that particular blade? And the moment you figure that out, saying that 3 blades need to be changed, those 3 blades are changed. The whole set isn't changed, because ultimately the reason for the change was that the theoretical limit, safety limit of that part was 24 months. The cost reduction is 90%. The revenue lift for G is about 90%. So that's the side of exponential thinking that companies are coming in, saying that we won't do 5-10%. We're going to use 3D printing to print the ceramic blade. We're going to use live machine learning to sort of just pick up and compare, because a human is not going to sit and compare whether that gauge has changed or not. And we're going to put this ecosystem in place at every airport or every workshop, so that changes the game completely in terms of blades and maintenance of these machines. There are many smaller trends, but I just thought that as you start your careers in the world, just think of how are companies thinking today. Every company is thinking along these lines. How can I have a platform? I don't want to be a product company. I don't want to be a process company. I want to be a platform company, right? That's the question everybody's asking itself, everybody. Second, how can I be completely autonomous? And I know it doesn't sound very right when all of you are graduating and going to be looking for a job, soon in the job market. But every company is just thinking, how can I be autonomous? How can an Amazon warehouse have no person, right? Just robots will do all the job over there. How can a vehicle not have a driver? A driver is 25% to 30% of the cost of the journey. How can that just vanish? And the third is, how can I work on exponential problems? Because if I don't do it, so if GE doesn't do it, a startup like Uber and Amazon is going to do it, and they're going to kill big companies like Walmart and Target and all of that. So unless you're thinking like a startup exponentially, then you're not doing it. So that's the mindset of companies, and that's the mindset I think you should approach your career, because no one knows. If anybody tells you what's going to happen in the world in the next 10 years or 40 years, trust me, no one knows what's going to happen. But as long as you think on these lines and keep attention towards the trend, you'll be in good hands. So that's the first part about trends. Happy to answer some questions, but I think that's not the topic of today's discussion. So there's lots to read out there on these three things. Second is what's happening in the chemical industry, right? So the chemical industry is petrochemicals, where I belong. So we counted part of the chemicals industry. We talk about agro, pesticides, weedicides, everything that goes to agro to help, that with that. Pharma is a chemical. It's taken as a separate industry because of the regulations and everything. But at the end of the day, a lot of chemical engineers go into the pharma industry. And then plastics is again part of the petrochemical, but that's become a big significant plastics, textiles, rubber, all of those end products have become pretty big in themselves. So if you look at the chemical industry, what's happening in the chemical industry? So one, companies like ours in the refining and petrochemical are going through disruption. There's nothing short of that. So every time an Uber becomes successful, we think that, or renewable energy or electric car comes in, we think that the amount of transportation oil, the transportation fuels account for, I would say, 50% to 60% of a refinery. I think even more actually, 65% of our product is transportation fuel, that's aviation, all of those. So that's going to go away. That's going to become all electric because electric is easy to automate. So if you want autonomous is easy with an electric vehicle because you have to manage a few things versus the combustion engine, right? So that trend is happening with trains, ships, planes, everything will just go that route. So we're going into this big cycle called, in fact, we're looking at a program called oil to chemical, where you today converted oil into only a few chemicals and most of it was transportation fuel. But how can you convert more and more? So from 35% to chemical to 50% to 65% to 70%, and drive that whole change, which really means new molecules, new products, new compounds, both in terms of production and R&D. That's one big change in the whole petrochemical industry. The second change is the pharma industry is going through a lot of disruption. There's an intense competition between chemistry and biology. Chemistry is easy to solve, find a cure. Because it's mass, right? You make it once and you give it to everybody, it's not personalized. Biology is much tougher, but the promise is much higher. In fact, if you look at this vaccine debate of COVID, the Moderna vaccine is actually, I hope all of you are familiar with a little bit of biology like DNA and RNA. This is an RNA vaccine. So you're no longer putting a chemical or a virus there. You're putting the RNA code, which is similar to the virus, and the body thinks there's a virus, and hence the antibodies are developed. And personalized medicine is beginning. So there's an intense competition. So will chemical engineers win that battle? And then there's the cosmetic industry and the other industry, and what's happening with Fair and Lovely. So everybody's talking about becoming completely natural, no chemicals, no plastics. I don't know whether it's a fad or it's there to stay, right? Time will tell. But there's this intense threat. Like, have chemical engineers produced all the carbon in the world, or all these things in the world which are polluting the world, and will that tide change? Right? It's not all doom. Let's look at the flip side, the opportunities. The opportunities is like you guys have done all the damage to the world in terms of carbon monoxide and everything, and and pollutants and non-degradable plastics. But guess what? You are the guys who are going to reverse it as well. So every technology that's coming in to make things carbon neutral, suck carbon from the air and put it into whatever, battery technology or someplace like that, or make everything biodegradable suddenly, that's still chemical engineers, right? So this changing the cycle from non-sustainable but value generating to sustainable value generating is a big industry that's coming in. Second, if you talk about, there are more destructive technologies like this battery technology, right? We need much more efficient batteries to keep power. If you talk about crops, we need micronutrients, more focused technology for crops. We keep talking about We need a lot of revolution in agriculture to take it forward. We talk about water. I mean, water is going to be the biggest battles in the future are going to be fought over water. How do we make water cleaner? It's all chemical process, right? So that's where people come in. So if you look at the whole, if I were to place my bets on where is chemical engineers going to make the biggest impact, it's going to be on the sustainable industry, that sector. So you have to really think away from the companies that are manufacturing together, but work with them to build the future of chemistry, right? So, and if you think about it, there's nothing incremental about it, right? You're not going into, let's say, a buyer and improving their process by 10% or 5%, because the world is not looking for those are not the biggest problems in the world. So we're looking at a disruptive change in the chemical industry from this non-sustainable image that it has to a big sustainable image, and there are lots of things happening across the world, to sustain that. So that's, I would say, where the opportunities are in the chemical industry. And when you talk about the last part of this part is, so we understood the trends, we understood where the chemical industry is going, and you probably, and I'm not a chemical engineer, you're probably closer to the chemical industry, so you know more trends as well over there. But the one trend I want to call out there is sustainability. If you want to think about that in agriculture, water, plastics, and use of those materials, all of those where sustainability is an issue. Battery technology, these are the ones where the biggest opportunities of the future will be. When you talk about digital, digital is impacting the industry today in 4 areas, right? So the first is growth. Every time you need a new compound, you need a new chemical, you do a lot of simulations these days on computers before you even start testing in the labs. So that's a great part of the chemical part, where every time you're looking for a new compound, a new composition, a new way of mixing things to create a new product, that's going to involve a lot of data, a lot of digitalization. That's undergoing a change. Second part is in terms of, you're a process industry. So if you can, and process industry has been around for a long time, but we're moving away from a process industry, which is, so the old way of maintaining a process industry was preventive maintenance, right? So like the GE example, you go and you inspect the part, you change the part in 24 months. The new way of doing it is predictive. I am going to predict when the machine is going to fail, and that's the perfect timing of maintaining it, right? I'm going to predict when I need the part, and I'm not going to have any inventory. I'm going to 3D print that part, and I'm going to use some advanced polymer instead of a metal, maybe even, to use that part. I'm going to use a better optimization program to. I'll give you an example. Today we get crude, right, from different countries, but the property of crude is different in each and every well almost. So Saudi Arabia well number 32 will have a different property of crude. So we call that the assay of crude. Today we don't even have the amount of data technology to basically pick up the assay. We pick up the sample of the assay of the crude and convert it to, let's say, averages and stuff. And then we use it to saying that, okay, fine, if I have these 3 types of crude, this is how I can combine it to get the biggest throughput, right? So you have a process industry, you're interested in maximizing your throughput through simulation. But if we had more data power, then we could actually pick up the assay properties, which is actually a matrix of properties where there's no averages, right? Like Amazon is not treating you as a segment, they're treating you as you individuals. There's Rishikesh buying behavior is this, Shalini's buying behavior is that. So the recommendations are almost personal, right? So can we get down to that level in terms of sources of oil to give a jump to whatever we are doing, right, in terms of productivity over there? So that's the second part, where the process can be improved either by changing the maintenance part or by changing the process engine, the cycle. right? So that's the simulation part. And the third part is basically looking at this whole circular economy. Like, how do you actually facilitate something that goes out of your factory to come back? That problem we haven't solved. Everybody says this plastic bottle is biodegradable, but can we really achieve that whole cycle and chain and bring it back to make it and extract the full value? So these are the three areas where, four areas I would say, which is R&D, products, revenue growth. Second, maintenance, where you start predicting which machines will fail and the process industry becomes more efficient. Third is in terms of simulation, right? So chemical engineering is always about combining different chemicals, different temperature, pressure. What's the most optimal mix to do that? And the fourth is this whole circular economy of making sure that the material cycle, as it moves from oil to chemical to a product in a car to back towards that, is fully tracked and moved around, right? How can you do that? So with these three things, I'm going to stop, hand it back to